Welcome to This Explainer. Today, we're diving into something we literally use every single day, but rarely think about: the invisible infrastructure of computer networks that completely powers our modern digital lives.
Think about it. Every time you jump on a remote call or stream a 4K movie, there's a vast, unseen web doing all the heavy lifting behind the scenes. But how exactly does that signal jump across continents and end up right in the palm of your hand? Let's figure it out.
Here's our roadmap for today. We're moving from foundation to future, connecting our digital world, understanding broadband internet, bandwidth versus throughput, the evolution of mobile networks, and finally, the awesome power of 5G.
All right, let's get started with Section 1, Connecting Our Digital World, Building the Foundation.
At its very core, a computer network is basically an ecosystem of devices sharing resources and data. Whether they're connected using physical wires like Ethernet or totally wirelessly through Wi-Fi and Bluetooth, this giant web includes everything from massive enterprise servers all the way down to those little smart sensors in your home.
And these networks form the absolute backbone of modern telecommunication. They bridge vast distances so we can instantly and securely exchange high-quality media. It's the exact same underlying concept whether you're running a massive global meeting or just, kicking back and streaming a show.
Moving right along to Section 2, Understanding Broadband Internet, Beyond Dial-Up.
Remember the agonizing sounds of dial-up? Well, broadband thankfully shifted us into high-speed, high-capacity territory. We've got DSL and cable, which leverage older telephone and TV lines. Then there's fiber optic, which literally transmits data using light through special glass wires. How cool is that? Plus, we have satellites beaming signals down from orbit, and of course, wireless options like our mobile networks and Wi-Fi.
Okay, Section 3, Bandwidth versus Throughput, the highway analogy. Let's clear up some confusing terms. So think of bandwidth as the number of lanes on a massive highway. Usually measured in bits per second, it represents the absolute theoretical maximum capacity of your connection. If you have higher bandwidth, your digital highway is incredibly wide, which means a huge amount of data can travel all at once.
Throughput, on the other hand, is the actual number of cars that make it through rush hour traffic. This is the real-world speed you actually experience. You know when you're watching a high-def video and it suddenly starts buffering? Yeah, that's a throughput issue. It's usually caused by network congestion, maybe some signal interference, or just sheer distance. Because honestly, it doesn't matter how unbelievably wide your bandwidth highway is, if a massive traffic jam is completely destroying your actual throughput.
So, just to lock this in, bandwidth is your digital highway's absolute theoretical maximum capacity, while throughput is the actual, real-world speed you get when your devices are trying to talk to each other.
Which brings us to Section 4, Evolution of Mobile Networks, Cutting the Cords.
Moving away from fixed, wired connections, cellular infrastructure absolutely changed the game. Instead of cables, we use cell towers that broadcast over specific geographic areas. This ingenious setup allows our phones to seamlessly hand off connections from one tower to the next as we travel around. No cords required. And the technological leaps here are just staggering. Think back. 2G brought us those early, simple text messages. Then 3G introduced actual mobile internet. And then 4G totally revolutionized the entire experience. It gave us high download speeds and incredibly low latency, making things like mobile HD streaming and real-time multiplayer gaming totally possible right from our pockets.
Now for the really exciting part. Section 5, the power of 5G, connecting the future.
Listen, 5G isn't just some minor bump up from 4G. It's a monumental shift in how networks actually operate. Yes, it provides super fast speeds, but arguably more importantly, it offers almost zero delay. We've all been in a crowded stadium or a super busy airport, right? Your phone shows full bars, but absolutely nothing loads. Well, 5G was built to solve that exact problem. It provides a highly stable connection that can handle a massive number of devices all at once, without slowing down, even when you're in the most densely packed environments.
And because of these incredible speeds and that practically zero latency, 5G is what actually unlocks our futuristic applications. We're talking about running highly advanced augmented and virtual reality straight from the cloud, completely on the fly with no lag. It's also the critical backbone we need for autonomous vehicles because it allows self-driving cars to communicate instantly with each other and with city traffic systems to keep everyone safe. Plus, it fully integrates our physical and digital lives through the Internet of Things, effortlessly connecting millions of smart devices across our homes, massive factories, and even entire smart cities, making the whole shebang run incredibly efficiently.
And that brings this explainer to a close. But I want to leave you with a pretty fascinating thought. If 5G is what finally makes smart cities and self-driving cars a reality, what unbelievable wonders will the 6th generation bring to life? As this invisible web grows faster and becomes even more deeply integrated into our physical world, the possibilities are literally limitless. Thanks so much for diving into the invisible networks that connect us all.